Hi, Luke. Well, good morning. This is a continuation of the Game Jam live stream. This is I got 24 hours with a zip file of unknown content. I didn't know the language, the game engine, the game type, anything. And I'm the third person to get this. We're going through 10 devs. We're going to see if we can make a game by playing telephone with a bunch of code. So where we left off, let me show you the game in its current state, is we got the workers in this game, which are represented right now by these red faces. Got them moving. They're kind of idling. And then workers can be selected and then given a target. And then they'll walk over to that target. So we were working on finishing up that and then getting them to go up and down these elevators that show up at the ends of the level. So let's see what's going on here. I hit a breakpoint. That's what's going on. All right. So I'm selecting. Let me select this guy and tell him to go over to this elevator. I'll select this guy. You go over. No, I tell him to go over to a room, and then he'll pathfind through the elevator. That's what it is. So we may want to make a mod to that to have him pathfind. I guess. Well, I don't know where he would go. We could make him go to the elevator, but he wouldn't know. So this guy went to the elevator, and then he warped down, which is great. So now we want him to continue pathfinding towards that room. And where we left off, the reason this broke is because the elevator, so I originally gave him the room target. And this is kind of common in games. You have a target location you want to send your character to, or the actor or whatever, and you can't go directly there. First you got to make a stop. And so what we do is we change his target to this elevator. Well, what happens is we need to know where the original target is so that we can keep going there. So we need to store like an intermediate target state. And I believe that was what was happening. I was a little bit tired yesterday after cranking out all day before I had to go to sleep. So this movement request towards variable is where we're actually headed to. And I just had added this but didn't wire it up. This movement request towards room variable. And we need to get that needs to basically always get set, never get stomped, unless the actual target's being changed by the user, the player. And this one is the one that we'll use as kind of like our temp or intermediate variable. So let's wire up this movement towards room. We have a set room target. So we're going to make sure we capture, what are we calling this from? When you're clicking on a containment room, we get the entrance door position. All right. So that's great. Let's go back to that func and then make sure we capture that now. Let's add a little comment on this. Just say entrance door position is kind of the intention. And if someone wants to change that, they can. Maybe update the comment. And so this might be the entrance door or the elevator if necessary. So now when we change, let's see where this is being set. When we change this thing to the elevator position up here on this code, when it gets ticked every frame, we say, hey, if we're on the floor, we're not idling. Movement has been requested for this guy. If he's on an elevator, let's warp him. Let's ride the elevator. If he's not on our level, if the room that we're going towards, so we need to change this. It's a room now. If the room is not on our level, ride the elevator towards that room. So now we just change this to check to see if we have that. Instead of what was happening was this movement request towards was getting set to the elevator position, and then this logic would break. So now, let's see. When we're idling, we want to make sure that this thing's always vector to 0. I don't know if this is going to matter, but let's just make sure it's in there. Since we've added this new variable, make sure it always gets set to 0. If ever idling gets set to true, then we'll make sure we don't have a room target. And now, if we're on an elevator and we're headed towards, so we probably still want to make sure that we're checking the room. If the room's not on our level, we don't want to check the elevator. Ride the elevator towards the room. Else if, let's see, the room, move towards the elevator position. And so let's see what happens after you ride an elevator, which would be ride the elevator towards the room. We'll be on an elevator, so the next tick, so this will take us up or down. Then we'll still be over an elevator, but it will be hopefully on our level. If not, we'll ride it again up. And so if the room is on our level at that point, after we've ridden an elevator, then nothing will happen. So in this case, we're going to have to set our move towards target to the room itself. So this basically will let us stomp the elevator's interstitial position. And see how this if is it's inverted like this? I don't generally like doing my ifs that way, just so it reads better. So I'll flip this. So if the room's on our level, then make sure we're headed towards the room. Else, ride the elevator towards the room if we're over an elevator. See, it reads a little bit better. So let's see if that helps us out, changes anything. We might have some more cleanup to do, but all right. So we'll pick one of these. We need to fix that bug where they all get selected at once. Okay, I want that guy to go up here. I want this guy to go maybe down here. This guy can go here. This guy go down there. This Elizabeth go to the top. Kyle go to the bottom. Kevin go down here. And now let's see if they ride the elevators up and down properly and then head towards their room. If they do, we'll just double check some cleanup, and that should be good for that bit of it. Okay. So interestingly enough, they warped. So they warped up the elevator, but they warped to the room. Can you see that? And that is, let's look and see how our ride the elevator works. So ride the elevator towards the room, and this thing is going to say, it's checking to see if the room, the target position, is above us or below us. And then find the lifts that are either above us or below us, the elevators. And then get the closest one and then warp us up to the right Y target, and this is weird here. So we're finding the closest lift. We're setting our position to the position of the closest lift. I'm not sure why we're doing this. Warping to the target position and to the exit position. This should be all we need. Let's double check that. Let's take this out. Let's just see. Because if we have the closest lift and we go there, I don't know why we would need anything else. So let's send Kyle up. And Kevin, you can go up. And Elizabeth, you can go down here. So we've given them each a destination that's on a different floor. So we'll see what happens here. Hopefully they just warp from the door either up or down, and then start walking over towards that room. Down, start over, down, start over. So that worked out really well. Try to get, so we got Kevin. Kevin, just go to that door. Alright. Not sure where Elizabeth's headed. I'm not sure where Kyle's headed. Okay, so she was headed, Elizabeth was headed here, as was Kyle. So we have this, also there's like a bug with this, how the selection stuff was written. But the good news is this stuff's working. So I don't know if I like this multi-select, the way it's working, because they're stacked, but let's not get too in the weeds here. Now we have the characters riding the lift, so let's look and regroup. Yeah, we didn't need any of this malarkey. Boom, done. Let's see. Let's just double check that we got good. It's the interstitial target. It should store overall target. And then this triggers the movement logic. Say enables. Else will go into idling. Okay. So now we've got the situation where we have our character going to those doors, but they need to now warp into the room. And so we got a couple situations to deal with. One is that the bug with the selecting, when you select these guys, the workers, I don't like that bug where they, where I'm like multi-selecting basically. And so let's look at where that all gets set. It's the selected property. Let's just look here how it gets set. Worker selected, selected, selected. I don't know. On deselect pressed, get nodes and group worker. Looks like we have What is this? What script are we? Player camera and pew. Okay, I don't think this is actually hooked up. This stuff in this pew folder, I think that the programmer named Celogen took out all the pew stuff. So we have to look at the Celogen scripts. So selected, gets set here, and it gets set here to false when they start when the worker is instantiated. We're reading it here a couple times for debugging. It gets set again here when we set the room target so that we don't keep moving them around. The body.set selected triggers whenever the selection box is detected an object. So whenever we select a body and it is a worker and they're not in the selected list, we append them to the selected list. So that's how the multi-select is working. Okay, so that's multi-select. I'm not sure how. I wonder if this is getting triggered multiple times somehow. Whenever body entered, okay. So the interface area, connect the signal will be triggered every time the selection has found something. So I'm wondering if this body entered thing is actually triggering multiple, like it's happening not just on mouse activity. That's why when they cross over each other, they'll select each other. I think this causes a bug where workers crossing each other select each other. So we'll just leave that as a note for right now. I don't know if we need to try to fix that. The other bug that we've found, let's just add this here, known bugs. We've got multi-select is buggy for workers. Is buggy, they cross each other and get selected. They don't respond to mouse click sometimes. And then we also have worker speed goes way down after they have a room target, and that room target code is, I don't like this UI at all. I keep clicking up here, which are, these things are like entities that are in the scene graph, and I am actually working on the code right here, and this has a left menu instead of this tab menu, so this tab menu is unrelated to this code. And it looks just the way it looks because it makes it look like it should be part of it. Worker speed goes way down after they have a room target. And then we got to remember, where was that? The room target is this thing, this variable name. I'm just going to put that in there for the next guy. Just do this. Okay. All right. So we've got containment rooms. They were now clickable. We worked that last night. And then now we have workers try to go a room. And now we have workers ride elevators. And now we want to do workers go in to containment rooms. I think it's the next step. So let's get that working. And let's see our scene here. Oh, zoomed in on that worker entity. So what we want is as these workers like wander around and they finally hit their entrance door, to warp up to the containment door that's related to the room that's related to that entrance door. If that makes sense. So it makes me think we need a way to we need to first we need to check to see if we're over an entrance door, and then we need to be able to find the room given an entrance door, and then we need to be able to find the containment door given a room. So that's going to be our goal here is, is over entrance door, find a room given an entrance door, and then find a containment door given an entrance door, and then warp the worker to the containment door position. And then we probably want to set the worker on idle. And eventually this will be work. Like, eventually find, monster to work on or idle, I think. Now, this is the funny part is that I don't know what this game is actually truly about. It's kind of supposedly some kind of a roguelike, where you're controlling these workers roaming around this factory. They have to go into these rooms. The rooms have monsters that you work on, whatever that means, and then you're basically building up stats of some sort or gear, and then I guess the monsters may decide to fight you or whatever. So there's a little bit of potential drama there, but a lot of it so far is just pathfinding. And so, given that I'm not too familiar with this gameplay, I've never played any of these games in this genre or really known about it before yesterday. I got this zip file. I'm going to work on systems and things that are sort of unrelated to the genre, so that the guys who know about the genre could just get straight into making the game part fun. So really I'm working on this frameworky stuff that always has to happen, and generally people don't enjoy quite as much because it's not the flashy stuff, but it's really pretty core to every system. So it's kind of the most applicable in some ways to all games. This is kind of what we're doing with this pathfinding. There's a zillion ways to do pathfinding, but ultimately the only right way is the way that works in your game every time. So don't get too hung up on what the right thing is. All right, so let's get back to our task at hand. We need to figure out if we're over an entrance. So let's go back to our script and go back to our worker script. And this guy here, we made this function is a room on our level. So we also want the function for is over an entrance door, and right now I'll just return false. We want let's see here. Let's just see if we'll ask. So this is the other thing I was talking yesterday with folks is, you got to learn how to use AI, and it's basically just, imagine it as like a fancy search engine it not just finds the results, but then sort of summarizes things for you. And so it can do decent with code. So let's just give it all this code in this file. I've been doing it already, so it's got a little context built up. And then we're going to just say, hey, implement this method. And it's probably going to fail, but every now and then it might do a decent job. So I'm wondering if it'll actually use this, find entrance doors script for us and do something like that. So it's saying find all the containment rooms, and then for each room use this get door position. So that's not an actual thing that exists, so that's not going to work, but potentially it's on the right path. So what we do have in rooms is when you're on a room, you know you're on a room because it's a containment room scripts on it. That's how we're doing the check currently. We do have the get entrance door and the get containment door. So what we actually need to do is get all of the containment rooms and then look over all of their entrance doors. So let's do that. We'll do find containment rooms. Our rooms equals find containment rooms, and then I believe we have, I'm still learning the syntax. I've never used GD script before, so that's another exciting part about this whole thing is I don't I don't know much about it. So using AI, I'd speak to it in with my understanding and relate it to concepts that I know. For example, if you know the web or Unity, ask it to relate it to those things, and you can kind of learn the syntax just by looking at the code that's produced, and you get used to it pretty quick. And in a few days you can be fairly competent with something, with a new language. So we're going through each of these rooms. We don't necessarily need to know the room's global position. What we want to know is the entrance door are the ones that are down below the room. So we want to say it's the room dot position entrance door spawn. Entrance door spawn, and we basically want to say, are we over? So let's give this back to the AI and say, hey, use this thing, position entrance, use our current position and that thing to see if we are over the door. So essentially what needs to happen is, we look through all these entrance doors and we see if our character position is over one of those doors. So we give it some kind of margin like 20 pixels or 20 units or whatever. And then if it is, we know we're over the target. And let's look at this. What is the output here? So we've got all the containment rooms, and then we get the global position of the entrance door spawn. And if we do have that, we get our delta x and y, which is it's cool. So yesterday it was doing a different way of this calc, a different format, and I changed the code to use these two variables so I could debug it easier. And now it's spitting back the code in that format for me, which is really nice. So we've got this entrance. So now it's looking to see if we're pretty close to that door, and if we are, return true. So great. That's what we want to go back here now, where we're saying, are we on an elevator? And we also want to say, if we're on the floor, meaning we're like on the ground, we're not idling, movement has been requested. Let's just add an if here. If is over entrance door. Then right now we just want to say where we are at an entrance door. But what we actually want to do is, given the entrance door, well, warp. Now we want to warp into the room. So to do cam warp into this room. Oh, but we actually we don't want to know if we're at any entrance door. We want to know if we're at the entrance door for our room, because we're going to be passing by a bunch of entrance doors to the target room. So this one's going to be enter room. We'll have to implement that. And then we'll have to update this with a position. Room position. So we'll have AI do that. Update to make sure we only care about the room at room position. Okay. And we'll have to fix that, I think. So we're probably storing just the entrance door position right here now, not the room position. So we want to add this enter room function too. And this thing is going to be, what I like to do is these to-dos, when I don't implement a method, so that it logs out to the console when I run over the code. Just kind of like a little breadcrumb for yourself, because we got multiple things to implement right now, right? We've got to do this code. We've got to, let's see, update this entrance is over entrance door to make sure we're only caring about the target room and not just the fact that we're over any room. Okay, let's move this function up a little bit. Get it so we have these two next to each other. Is over entrance door. So now let's see what it's changed here. The change is if the room global position distance to the room position we're sending it's close enough. That this is really all that was added to that. It's just filtering that room's position. So I think that's gonna mostly work, except for the fact that this movement request towards room variable, we're setting this bad boy, and I believe we're setting it to the entrance door position. And what we actually want is to have we actually want to set the room position and then get the entrance door position given the room. So the answer here is perhaps instead of set room target taking a position, we actually just have it take the room entity. So let's just hand this back to AI and say we want set room target refactor to take a room object instead of entrance door pause. And then over here we'll pass self instead of self name, right? So instead of this, we're going to pass room, and now we'll have room.name, and what else? Get entrance door position. Room.get entrance door position. And now, instead of capturing this room position, we'll just capture this room. And this is a room entity. That's not the right, I'll say object. I don't know if they use the word entity in Redot. So, again, I've been using it for less than 24 hours, so it's kind of it's a crazy competition thing that we're doing here. We've got, this is not a vector 2, so we need to, we'll have, let's see, our room variable here needs to actually be the right type. Since we were capturing the position before, and now we're capturing the room object, and the room object is what? It's actually a character. This is the worker. Wait a sec. Worker set room target self. I keep doing that. I keep clicking on the thing. It's a class containment room. Refactor room target to take containment room object instead of entrance door pause. So let's see if the AI is going to give me the new properties up here while we're working. This is our worker, and we think it should probably be something like this. The containment room entity. And so set room target. And so the syntax for making sure this parameter has a type is this. And then it's saying void now, which means it's not, this function doesn't return anything, it just does some stuff. And this wants to be a variable, so we use it twice. Entrance door pause. So far, and then we use it 3 times. 1, 2, and 3. Okay. So this is our, like, actually where we're trying to move the character, and then this is conceptually the room where we'll want to go to. Okay. And that should perhaps work. So it's saying, hey, set this room target self. We've already done that, remember? And I think, so that should be good there. So now we've refactored this to take a room, and we move towards a position, and then now in our script where we are moving, where we're figuring out every frame, like where do we send the character. If we're idling, we do this idle block, just kind of moving them around randomly. Otherwise, if we're trying to get to someplace, because this flag is set, then we figure out, are we over the entrance door to this room? And so now this function is taking a room and not a vector, right? So we've got to update these. So we need to update this, and given this room, so let's call it target room. wonder if we can just say if room equals target room. Let us see. We actually don't have to loop through all the rooms. We just need to, now, since we have a room, we can just look at the door position. And we know it should because it is now a type of containment room, so we shouldn't need to do this. So now we just say if the door position is this, and if we're over that door position. So we've cleaned up this method because it's now taking an actual room instance. We're going to want, let's see if we use that same variable name other places. So enter room position. This might just be, we might just pass this a target room. Is room on our level. This one we'll have to fix. So enter room. So now we're passing, yeah, that's a room. We fix that. Now, is room on our level? That we're passing in the room, but this function thinks we're still taking the room position, so actually we're taking the containment room. And then the entrance door position was what we were checking before, so we'll just keep using that logic to see if it's, plus or minus. If the entrance is plus or, if, within 300 units of our y up and down, then it's on our level. That's how we figured that out. And then this function over here is taking entrance door position, and it should actually just take room now. Okay, so we perhaps we're close to finishing that refactor of capturing the room as a big picture target, and an interstitial targets might be a door or an elevator or whatever. We need to do all that so that we don't lose track of where we're actually going as we're pathfinding our character to not the target, but to the target that will ultimately lead there. So let's get back to where we were. What we were doing is over entrance door, which is this. And then if we're over the entrance door, now so if we're over the entrance door, then right now we're just printing we're over the entrance door. Remember before we were like, hey, are we over any entrance door? No, we don't want to care about that. We want to know if we're over the target entrance door, and then enter that room. So we know this, we believe this works correctly. We haven't checked it yet, but we believe that works. And then we want to do enter room, and so right now we just have to-dos. So let's just see if our code's running and prints out to-dos. Okay, so now remember we changed this to be a room, and now it's from a vector. So I think, is it nil or null? That is nil and null different. Let's look at any spot else where we're setting the room target. Okay, it's a room. Let's just see if that works. Movement request towards. Okay, so this is, hey, if we're on the elevator and the room's at our level, let's go towards it. Well, now we have to get the entrance door position instead of setting our target. This is where we're actually moving our guy towards, not the room to the entrance door. Okay, ride the elevator towards the room. So before we were giving it a target position, and now we're giving it a room. So I think we just give this the entrance door position as well. Ride the elevator towards that entrance door. That's what the data would have looked like before the refactor. We knew that worked. And then lastly, get the closest lift to this target position. So we can pass that same thing, or we could refactor these methods to take a room instead of a position. But we know that it works. It works either way. So, and what is this? A null room? Identify a room is not declared. Yeah, because we called it target room. We got rid of our for loop. This is the part where I hate this kind of stuff. Refactoring with scripting languages. When you're dealing with scripting languages, resist the urge to rename stuff and reorganize stuff because it'll break quietly and it breaks at runtime, which is a no-no for games. Alright, so we'll send one of these guys down. We'll send one of these guys up. Send one of these guys up over here. We actually don't care if they ride the elevator, so let's send them to a closer spot. This guy's going to go to this room, and this guy's going to go to this room. Okay, let's look now here. In our console log, worker is over the entrance door for room. We are at an entrance door to the target room. To do, enter room. So this is great, and this is also why I love doing the console logs for my stubs, because you can just highlight this, copy and paste it, and then find exactly that code to go fix. So this just happened to be a debug print. We've already implemented, so we don't need that one anymore. And right now we're saying, are we over the entrance door? Print it, and so yes. And now we're going to warp into that room, so yep. So we're going to implement this enter the room, which was this red one to do enter room. So that's the beauty of stubbing out your functions with some debug print and then coming back and implement them once you actually see it in the console. So now we want to, given a room, over here, find a room given the entrance door. Check, we've done that. Find a containment door given an entrance door. Well, it's actually, now it's going to be given a room. So the new target, the new position is actually to the target.get, let's see, containment room, position, containment door, spawn. And I'm not sure why we have a wrapper function. I guess it makes it a little easier. So let's just copy the same pattern so that things are consistent. Get containment door spawn. Let's just call it position. And this is actually this guy, this guy, this guy, this guy. Update position entrance door spawn. So we're essentially null checking that these properties were set on this containment door class. And the way it's actually over here, if we look at the rooms, you see this entrance door and containment door property that we've added. Those get, when you see this export var thing, that shows the properties up. In Unity, it's kind of like putting a serializable field attribute over a property. This export is kind of like that, and it's saying export it out, and then this inspector knows when it sees those to make these things properties that you can set in the designer. So now we're just making ourselves a little get containment door position function that does a null check, return 0 just so the game doesn't crash. Otherwise, get me the global position. Fine. We'll go with that. So given a door, or given a room, we'll get that door position. And then now we want to essentially move, like warp to that position. And so that terminology warp we used when we did the ride elevator towards. And so we don't actually need to like filter through elevators or any of that. We know our target position, and we're literally just setting position to that. So pretty easy. We're going to go back to where that is called, if it's called here, this thing, and set position to, we could probably just do this. We don't really need a variable because it's so simple. And we may want to print here warping. We'll just call it, we'll use the same terminology. Enter room. Just so that it's, we use the same, if you use the same words and names and stuff like that and not get clever and rename everything to be slightly different, then your find and replace is more useful over time. Your future self will appreciate your past self for caring just a little bit. Alright, big boy, I'll let you head over here. Okay, so he warped up. He warped up. Okay, he warped up. And, interestingly, he kept walking. So, this is cool. So now our workers go into the rooms. Alright, so let's make our notes here. We now, workers go into containment rooms. Awesome. This is great. So, the question is, what should we do? What should we do now? We got the workers. Let's look at this gameplay here. There's a lot of JRPG kind of story stuff with this. It's kind of funny. I'm looking for other system mechanic kind of stuff that we can implement. So you could imagine if someone had to, has to spend hours in doing the pathfinding to move these workers around, then it makes it harder for them to, the next person who might know about this game genre to make the game fun, make the game part fun. So we probably should implement getting the workers out of the rooms because they're kind of stuck. So if you click on a worker and then you give them a target that's out of the room, we need to be able to warp them that way. So let's go back and look at our worker, and this is our code block for where we're going to move to. So if we're over an entrance door and to the target room, then warp there. So what we probably need to do is kill the target room once we enter it, because what we don't want is to have this code where you warp into the room and then you're stuck in the room. You're like constantly trying to enter the room. Is that what happened for us? We don't know. Oh, because we're not over the entrance door anymore. Yeah, because what we're going to want to now check is, are they over the containment door? And if the target's not this room, warp them out. So let's implement that first before we start setting, like killing this target variable. So if we're over an entrance door, then to the target room, then enter it. If we're, let's see, it's LF. If we're over, if we're is over the containment door, and what's the state? So if we're over the containment door, which is the inside door, if we're over a containment door and our target and that containment door is not our target room, then we need to warp out. Leave room. So if we're over a containment door and not is in target room, then if we're over a containment door, we're in a room. And if we're not in our target room, then we need to leave the room. And warp to room dot, get entrance door position. So let's just see if AI is going to be clever and say, hey AI, implement this. So the cool part with AI, and it'll get better and better over time as we get better AI, more memory for context, is it gets better and better the more code you feed it, and it'll start recognizing your patterns and stuff, and just kind of do things the way you would do it. So it becomes kind of an extension of you in some ways as you train it. And I don't mean technically train it, I mean practically train it. Um, you know, for the next 10 to 15 years, you probably see the most job growth on the planet is going to be humans training AI, and ultimately, fairly soon, humans training Android kind of robots. How to do things. And once a human trains an AI and a bunch of humans train the AI, and the training overall is kind of similar and accepted, that'll become sort of part of the de facto standard. And then all the AI gets that update, and humanity is basically going to spend a couple decades training AI, um, and so that's kind of what it's kind of what's going to happen. So get ready for that. The next 20 years of basically just training AI how to do everything we do. It should be it should be exciting. It'll be fun if you're a part of it. It'll be dystopian if you're not. Uh, okay, so are we over a containment door? If we're in the target room, leave the room. So look and see if let's look and see if we have to change anything. Is over containment door. That's just a bool. Is in the target room is a bool. All right. Let's see how that goes. So we need to get. Nope. What do we got here? Oh shoot, missing. So if I would have listened, let's see. It would have told me, hey, put that colon there. This colon thing, not a big fan of that. I feel like their parsers should be able to figure that out. But okay, we're telling that guy to go in there. This guy. So now we want to say, hey you, go to this room. get. And so what actually had happened was everybody moved into the room. So they target room set is set at our level false. Okay. So what is happening? We don't know. We basically need to bop in here and see, are we going into this uh, like which one of these bools are we is failing, because I don't see the logging that's in here leaving room, so we're not getting into this block. So one of these bad daddies is getting it's not working the way we want it to work. So let's get this guy over there. This selection bug is kind of funny. Stop it. Okay. Warp up. Okay, so now we know we're over a containment door. And let's just see where we're at here on this. Are we over an entrance door? Nope. Are we over a containment door? Let's put our breakpoint in there. We don't, it's not null. Get the position. Delta Y, delta X. 18. Okay, so we're definitely over a containment door. Yep, so return true. Okay, that works. Are we in the target room? Get the containment door position. Oh, this is the messed up spot here, right? We don't really care about the containment door position. We just care that we're in the room. Yeah, so is in target room. Even though this is returning properly, this code is not correct. So is in target room should check the room boundaries instead of the door. Okay. That's a note to self. Let's get back out. So we gave it the room we were trying to get to. Oh, maybe that's the problem. We weren't. Were we setting the room properly? Is it getting updated? Let's make sure. We do set room target. Let's go ahead and log it out here. Set room target. Room dot name. Okay. We'll get AI working on the problem of it's just checking the door as to determine if we're in the room or not the room itself. And then this. Let's go ahead and run it. Interesting bug there. The cursor, it's like a Godot bug. Okay, so these guys are up in their rooms, and I don't see. So we warped them into the room. Are they still getting run here? Let's see. So this is failing. Is in target room. Must be returning true. And so the question is this not giving a new target? Let's see. click this guy, and I say go here. Yeah, I'm not seeing any. Where's my console at? There. Okay, I'm clicking containment room, and I'm saying go to left 1. Okay, is that the right? Let's do this one. Go to left 3. Okay, that seems right. It's a set room target for that guy. Let's make all of them that. Alright, so that this, when we debug in here, we don't have to worry about which person, like which worker we're looking at. Okay, so do we have a locals? Local. And do we have movement request towards? Okay. Object ID. Let's just look at this name and see if it's that left 3 thing. It's a containment room. Where's the name? Anyone see the name? I wonder if that's a base property for nodes that you don't get to see easily. Okay. Well, let's just go in this function and see if we can get better debugging. Oh, we're not. Are we not getting over a containment door? Is that not working out for us? Let's try this. Door position. Delta X. Oh. So we're not. Okay, so what we did was we changed our room target, and instead of checking it if we're over any containment door, we're checking if we're over the target containment door here. So what we actually have to do is look over all the doors. So where are we at here? Is over containment door needs to check all the doors. Check all the doors instead of the target. Okay. So while it's crunching on that, let's see what it fixed here. Because we said, hey, the target room should check the room boundaries instead of the door. So this is in target room. Do we have collision area in the room? That's the question, right? Room containment. That's a script. What was... I don't remember if the name of this... Did we have a collision area? Holy monkey. This looks a little funky, right? Looks like it died. Alright. Does this thing have a collision area? We will find out shortly. But let's go back here and see. In the meantime, if it did our loop to be over all the doors. Instead of the target door. Yep, for each room. Okay. Now we're over the containment room. Yep. So, let's see if that updates our... Is over containment door is the same. Do I have two of these same functions? Oh, I didn't paste over it. I added two. Alright. is over containment door. Let's just see if we ever get into this leave room now. Okay. It's not. We've somehow like breakpointed ourselves into this. Okay. Don't. Why? Okay, I don't want this breakpoint anymore. A function is in target room not found. Okay, that's the problem. Is in target room. Oh, what was this called before? Did we is in? Did we lose that method? I wonder if I pasted over it. That's the I've pasted over is in containment room when I did is over. That's why we had the double method. Okay, so coming back again. It'd be nice to have a compiler that told you what was going on, like when that method was missing, instead of running it, finding out. Okay, I don't know why we're breakpointing in here. Oh, probably because it's broken. Non-existent function has. So this is this pattern that the AI is trying to do, which is to be smart about checking properties. But we know that's a type in it of containment door, containment room, and it's going to have doors on it. So setting the room target. Okay, worker is over containment door. Now give it a different target. Leaving room. Warping. All right, so cool. We've implemented room to room warp. It warped down here. Instead, we want to just warp out of that room, but we're getting close. So worker is over the containment door. We can get rid of that because we know it's working now. And we know that this leaving room thing, that might be where we're dying out here. So we're saying leave room, and it's taking a target room. And I don't know, we actually just want to leave the room we're in. It doesn't really matter where our target is. It's because we want to leave like the current room effectively. So we want get current room. Let's just implement that. So we'll give this to AI. Say implement get current room, which should just do a loop over the rooms and see if we're in one of them, and then that should be pretty simple. So yeah, so it's just getting the rooms and doing a loop over the rooms to see if we're in it, and that's it. So again, this is the thing of the AI. It's not replacing you in the sense that you still have to think about what you want to do and how you want to do it, but it's nice to um, it's nice because that this code here, it just saves me from writing a dozen lines of code that I know how to do. I know how to write it. I've done it before. We've done it over and over. It's not super interesting to write, so I just need that code written. I don't need to be the one to type everything every time. It's kind of silly to worry about that, because if you were truly worried about that, you'd probably write everything in binary. Everything on top of that is an abstraction, so kind of pointless. So what we're getting here is invalid argument to leave room function one should take a containment room, but is callable. And so I think as the problem is I'm passing a function, like a pointer to a function, and not calling the function by having these parentheses. I believe that's probably what's going on with the scripted language. Okay, so let's grab one of these bad boys again. Say go in here. Let's see if he gets up into that room. Okay, he does. And now I want him to go to this room. And it's saying worker is not inside any room. Okay, so that's good. Stop this. Where is that failing? So we're failing to figure out, we're failing to find the current room. And it's probably because we don't have this collision shape on our room. And it's looking to see if, like, this is how it's figuring out the room size. And our rooms are actually over here on the left, and they have what? A transform. So that gives it a position. What do we have inside of this thing? It is a containment room scene thing. So we've got to come down. So this is how it's defined. Okay, so it has a collision area. So let's give this back to AI and say, hey, so fix uh, get current room. We don't have collision shape 2D. The attached image is the tree. And let's see if it just immediately picks out which one of these we should be using. So, right, are we using this collision area or are we using this background? It's really probably the two options. And so it's okay, so it's going to check the background and just get the texture size. So kind of like the visual, the what the thing looks like in the game, it's going to just use that size for the boundary, which makes sense. It's not always the case in games. Uh, kind of famously, in FPSs, there's the hitbox, and so the hitbox is a thing that's in almost every game, and that it's rarely ever the mesh that you're looking at, the image you're looking at. It's usually smaller. Games that feel unfair, it's because it's usually bigger. So like in Super Mario Bros, the piranha plant hitbox is really like half the size of the piranha plant. So your feet can touch the mouth of the piranha plant and you won't die in Mario. So you know it makes the game feel more fair. It makes it feel exciting because you think your brain says, "Yo, you touched that, but you survived." So it's more of an adrenaline thing. If you get close to it and then you die, but you didn't touch it, now it feels brutally unfair. So you can mess with the hitbox to really give a different. Hey, we just warped out of that room and now we're pathfinding down to the bottom here. You can use hitboxes to really change the feel of the game. Invisible hitboxes that don't look like the actual thing that you're trying to get through, uh, or the thing that you're trying to collide with. Okay, so let's just see if this works. I've selected Kevin here. I'm like, Kevin, go to the room next door, and he doesn't. Okay, this guy is pathfinding pretty well. Kevin, can you go to this room? No. How about this guy, Elizabeth? No. So these ones are having a hard time getting out of their room. Let's look at our debug log and see. Did this guy? He's trying to make his way over. Oh, this guy did end up leaving. Interestingly enough. Elizabeth? set the room target to right 2. Okay, so warped in. Let's change Kyle to this room. Okay, so Kyle's actually... Okay, so what's happening here is essentially if we're in a room, we need to pathfind when we want to leave the room. We got to pathfind to the door instead of just towards left or right. Because you see this, Elizabeth's trying to get out, trying to go to the elevator, but not going to the door first because it's in the opposite direction. So we need to enhance this with pathfinding needs to go out of the room first. So that means when let's go back to our logic that basically this is our pathfinding logic block. Let's put that in there. Pathfinding logic block. Okay, so if we're on the floor and we're idling, we're doing moving left and right randomly. Movement requested means we're on a mission from God. And then if we're over an entrance door to our target room, enter that room. If we're over a containment door and we're not in our target room, leave that junk. And we should probably say if we're not in our target room, if we're in a room and it's not in our target room, move towards the containment door. Elif, are we in a room and not in our target room? Is this going to work? If we're in a room and not in our target room, we have to, yeah, so it's a little bit of nuance because it doesn't, if we just check if we're not in our target room, then when we're walking around, that'll get triggered. So this in a room is important. If we're in a room and not in our target room, we want to movement request towards, so get current room. Basically, if get current room is not equal to null, that's kind of like in a room, and we're not in our target room, we could check this in another way of saying it's get current room, not this. So if get current room's null, not null, and we're not in that room, then move towards get the, it's not the entrance door, right? It's the containment door. So there's a lot of like wasted cycles in this logic block. We're trying to do it so that conceptually it's easy to read. You know, we're looping through all these rooms constantly and just checking some stuff. It doesn't really matter. We're running 3,000 frames per second right now. So resist the urge to premature optimization because it literally doesn't matter. And so you'd spend time trying to fix some of this stuff or improve it, let's say, with air quotes, uh, for quite literally no reason. 3,000 FPS is plenty. Hold on a sec. This looks too indented. I don't know if that upsets the gods of GD script or not, but I don't want to take the chance because those bastards are picky. Okay, so this guy's in a room. These guys, let's send them up on a mission up here. I wonder if I can connect one of them over there. This multi-select thing's kind of pissing me off. This thing, okay, Kevin, you go down here. So that's nice, because right, he left the room. He's pathfinding the opposite way of this room. He's going to go to this elevator, come down, and then come back. Now, Elizabeth, on the other hand, here, we want Elizabeth to, let's see, what's a hard pathfinding situation? So Elizabeth needs to, oh, so Elizabeth got stuck on getting out. Okay. Okay, so he got back in, got out. So when leaving a room, they're getting stuck. So when they're leaving a room, they're getting stuck. Let's just confirm that. So I want to go over here. Okay, so that we're going to the right worked. Going to the left worked. Going to the right worked. What the deuce? Is it when we go to a different level? That seemed to work. That's working. That's working. Okay, so there's an intermittent bug, which are the worst. There's the bug you can't reproduce, very worst. Intermittent bugs, next worst. Because there's some kind of there's a case. This guy's like super anxious. He's like, yo, I need to get up this elevator, but I can't. Let me in. Okay, so we have an intermittent bug with exiting. Bug when exiting a room. And then we have bottom lift warping up results in like the Harlem Shake. Okay. Obviously this is undesirable behavior in humans and code. We've got to fix that. So what is happening? So we're getting quite a few log messages. You see 17,000. So we'll clean up some of this, because that's going to be running for a bit here. Worker is not inside any room. Yeah, so we don't need to print that out now. That was just for debugging. And let's see what I said about cleaning this stuff up. It makes it nearly impossible to find your actual logging that you care about. So we know that when we hit an elevator, let's go back to our pathfinding logic. When we hit an elevator, we were is on elevator, and is room on our level. Then we tried to move towards the entrance door. Otherwise, we tried to ride the elevator. And riding the elevator, we don't want. So the problem is what? We actually we don't want the elevator that even though it's close, it can't be on our level. So, ride elevator towards. needs to filter out the elevators that are within like 200 Y of our current position, because I think what's happening is the elevator's above us, but it's actually only a tiny bit above us. So let's see if that works. If the AI can figure that out, because like this, I think what the AI will do right here is look at this is target above and the lift position Y. It'll probably add a little bit of a buffer in there so that we omit the elevators that are kind of near us. Yeah, so it's doing this, checking this delta Y. Let's look at this code. Yeah, it's basically what it's doing. It's going to replace this for each lift and lift things. So right here, see how it's subtracting that delta Y and then saying it's got to be over 200. So make sure it picks elevators that are decently far enough away. All right. Again, use AI just to help you out. It's not replacing you, and it doesn't mean you don't know what you're doing. It's just doing that random stuff that, like, we're trying to think about conceptual problems. Why won't this elevator thing work? You can have AI figure out the up and down, y-axis math. You don't need to be the one who does that part. It's not. It's required, but it's not. It doesn't require a human. So next thing to do, man, probably be to fix this movement speed and figure out why these bad boys slow to a crawl when we give them a room target. Why does the movement speed slow down greatly when after worker has a room target? So we fix that bug, then this part of the story where we're, just sitting here waiting, we can test this stuff really quick, and we don't have to watch this slow crawl. Alright, we'll see where these are going. Is this one going up here? Going up here? So you going in, you go in, let's get this guy out, go to the room next over, and you go to this room next door here, and then we'll have him ride the elevator. So you ride the elevator all the way down. And this one I want to ride the elevator all the way up. We'll see if they get it. Maybe this one might go bop bop, we'll see. Haha, bop bop. That worked. Let's see, bop bop. Come on. Yeah, buddy. Alright. We are cooking with gas now. So, excellent work. We are doing it. You feel like a game developer yet? You should. You should. Now we need to figure out why the movement speed is so slow. That's funny. My, forever, that was my sort of handle. It still is on just about everything. So slow. It was my first custom license plate I had on a Trans Am that I drag raced. In college, I would draw terrible pictures of the car, from the behind racing and that kind of stuff, and I always wrote so slow on the license plate, so that ended up being the thing after I got the car. So it's telling us to go fix this move towards stuff, and it's saying maybe this 0.51 plus the property swiftness times 0.1 might be too small. Increase the base speed of property swiftness multiplier. So it's saying target threshold. Let's see. Oh, interesting. So it's also saying move requested should be set to false. Um, I had a little brain fart, so it definitely crashed in there. That happens a lot. I think that happens when they probably have to reboot these nodes, these AI, containers, however they're doing it, pretty frequently. There's probably memory leak or even worse, sort of like context leak, where the AI's got enough input from the humans that it's now just hallucinating all over the place, and so it has to kind of reset back to zero. So pretty frequently you'll hit an issue where the answer will suck or get crazy, like we saw up here where it just started spitting out gibberish, and then you kind of have to like reset it, and it tries to reset your context, but sometimes you'll end up you'll kind of know because you'll have to then like how sometimes I paste all the code in, it'll like start talking in a different language, and I say, okay, here, take all the code again. You don't know what's happening. So this has got quite a few updates here for us. So the position x equals move toward, that's one thing it wants to talk about. So let's look at that. Line 117. If move requested and move record is not zero, move toward is not zero, move towards it, and movement speed times delta. So we don't know. Ah, we're not incorporating delta in here. That's I think the main takeaway here is this math right here. When we're running 3,000 frames a second versus 1,000 frame a second, it's going to make us go way slower. And so once we assign a room, we get into different logic flows. It does run a little bit slower. Not like frame rate in the sense of you visually slower, but processing wise slower. So that could very well be the situation. Let's just try that before we do all this other stuff. And I don't know what this, because now we're timesing by delta, which is going to be like 0.000 whatever. This thing might have to go up a big number. Let's test it. So it needs to go up even a bigger number. Let's try a 200. We go up like powers of 10 until we get it sorted out. So that's a little bit more sane, right? Let's go up again. This should be jamming, and then we just start halving. Okay, 2 jamming. So let's have it down to 1,000. Then we just have it, and you kind of circle in like a binary tree algorithm. Okay, that's probably a little too fast. So now let's go down to 750. Okay, I'm kind of liking that. Probably a little too fast. I am kind of liking that, but let's just go down to the 500. And then we'll bop it up in 100 increments if we need to. No, it's good. We can still click it. Still pretty fast. We're not going glacial speeds. Greta's going to be happy with this. Probably unhappy. Never really happy, is she? Alright. Cool. Dynamite. So now, we've got our dudes in the rooms. They'll try to pathfind their way out. And they're taking elevators around. It's a party over here. So now once they get into a room, this guy's doing a little jig. But that's okay. Once they get into the room, they could be set to work, whatever that is. So, that's great. We've fixed the movement speed. problem. Let's go back to our notes here. Workers go into containment rooms. Workers can leave rooms up and down. Workers can leave rooms, and we've fixed the worker speed. We'll just say bug fixes. Worker speed, so we'll just say fixed here. And then we'll put in a parens here, was not being multiplied by delta time. And so delta time is how we do any kind of physics, movement, processing where generally like a distance is covered. You know, if you're having to throw a ball and it needs to get towards target, can't warp there or shoot a bullet. That has to go slow. We use delta time to figure out the steps, because if you're doing 60 frames a second and then 70 and then 50 and then 40 and then 60, what we don't want is that uh, when the slowdown happens to just move the same amount. A, a great example of when this happens is the original Legend of Zelda on the NES. Some of those rooms with a bunch of enemies on there, the logic that has to run is too much for the NES. And so the music goes into slow motion, every movement goes into slow motion, right? Until you can kill enough of the enemies, then it gets back to regular speed. So we don't want slow motion, and we don't want super warping. So we multiply by delta time, and that helps us basically even out no matter what the frame rate is. So we've fixed the Harlem Shake problem. We still may have the intermittent bug when exiting a room. We fixed the speed problem. We figured out the button panel stuff. This is this button stuff is notes from yesterday. I don't like those attack and the move buttons, but they may have to stay because of the ability to sort of multi-select. So, especially if the workers are stacked on top of each other, it's unclear how you would get them off of each other if you couldn't just single select out of that stack. So now what we need to probably do is figure out if monsters ever spawn. Do monsters ever spawn? We have monster containment. We have doors. We have the floors, which have these shapes to them. We have the lifts, which are the elevators. We've got those hooked up. We have the workers, so we've got these 3 workers in there. And I don't know, it's unclear to me how you get more, or if more should spawn, or if you just start off with that many or whatever. I don't know what assaulters are. I don't know what monsters are. Uh, we have this interface area, which I think is not scaling right when you zoom in and out. So let's just add that note to the next person. Uh, interface area in gameplay scene doesn't seem to scale with zoom level. Okay. This is, let's see, to do, misc to do is what are assaulters? What are monsters? Let's see, more sound effects. A win condition. let's see. Can more workers spawn during a level? Workers need to battle. Monsters need to attack. Okay, so these are things that need to happen for this to turn into a game. Uh, let's now let's get some monsters going. I think when we were digging through the code, there was a spawn monsters maybe function used by gameplay spawn monster. So Celogen, this is like the V2 of the code. The Pew stuff seemed like the V1, and it sort of became the basis for Celogen's refactor, I think. I could be totally wrong on that, but uh, it looked like Pew had done a ton of work. It's unclear if it's in there. So we could also go through his code and see if there's other stuff that we can like divine how it should work and roll it in. Now that we've got, you know, like our pathfinding's working, we're going in and out of rooms, going up and down elevators, we've got sound effects. So it's starting to be enough activity that we can actually do stuff. So we got spawn monster. It doesn't look like it's ever called, at least not in code. These are This is the function. Spawns a monster node into the garbage collection. It needs to be the monsters. It needs the monster's name and containment room node where it will spawn. Make sure to only spawn monsters which are unique and not identical to any other existing monster. So I think that means unique by name, or if it's unique by ID. Like if you have a monster called, Woolly Mammoth, can I spawn multiples of those? They just need to be Woolly Mammoth 1, 2, 3, or do we only spawn one monster type per? Okay, so we got placeholder, wild hound, feral cat, lone wolf, muscular cow, and killer gorilla. Okay, so we've got these guys. They've got. I wonder if there's a monster scene thing. Okay, they've got a collision shape, 20 pixels by 20 pixels, and an entity placeholder. So they look like this yellow thing. So, so there's that. There's not much to that. We've got to figure out how to get a monster is on containment. Where? Containment room. Okay. Setup monster. Like, is this ever called? Setup monster? It is. It's called in spawn monster. Okay, so spawn monster takes a monster type and where it's going. Love that so far. Uh, and then, so we make a new monster. We set it up. We set up its name. We give it a position. We set the room that it's going to. We set this property on the room containing monster. Okay, I see that. Come on. Let's see. The back button doesn't work with going back and forth between files. It's just where you're at within that file. So I don't like that. We set up the monster. Come on. And then we add it to this collection of monsters, which is what? Okay, it's just. So this is weird to me. What file are we in? We're in gameplay? Is that what this means? Okay, so gameplay's got a collection of monsters, workers, and assaulters. Alright. Okay. So we need to call spawn monster. And it's in this gameplay script. So what should we do? If you have been following along for 24 hours, I added a debug button early on so that I could just figure out how to play a sound. And now I'm going to add myself a debug button to spawn a monster. And that's going to go somewhere. There was a debug. I remember seeing a debug screen in the code somewhere. I wonder if that's a thing that we can bring back. Oh, I don't know. So for now, we're gonna just add. I had to use Visual Studio Code to find this thing, this attack button, and that was in selection information, the scene, and not the script. It was in this thing, and so no, not selection information. It was in. That's incorrect. It was in. It wasn't attack. It was SFX. What was the name we used? SFX stubs. SFX test. In this temp file. Sweet. Which temp file has this in it? Which real file has that in it? Gameplay the scene. So gameplay the scene, not gameplay the script. Gameplay the scene has. Oh, it's this UI thing that was hidden. There we go. So let's add another button here, and we're going to do our spawn monster in this bad boy. Okay, this is going to be spawn monster. And we don't need this audio play thing on it. We're going to want this thing, this button, to say spawn monster. And we want it to have, we don't really want it to have a script, do we? How do we wire up this button without having to give it a script? Clear. We would need to go to the script of this whole scene and then find the button named that and connect it to what, a signal? Is that what they call it in Godot? Okay, so gameplay, the script is going to wire up gameplay the script is going to wire up the signal. Do we have it ready? Okay, there it is. It's going to wire up our spawn monster button. So let's give this to AI and say, hey, wire up the spawn monster button in this ready. And let's see if it can do it as fast as we can do it. So I think it's .connect was the let's see. So we have to find the thing, which I think we do with a dollar. Is that it? .connect. And then we give it our function, which is going to be on spawn monster click. Is that? Oh, they like to use pressed. Pressed. And then we need to define this function. And then for right now, we'll just do the print thing. Print error. Okay. And let's see what AI came up with while we were doing that. To wire up spawn monster to the ready, you've got to locate the spawn monster button, which we did. It's giving it a different name. And then connect the pressed. So it didn't like how we did that. So it's saying this is how it's actually supposed to be done. So it wants us to do that. And then rig up this method. We just did a print on it, but it's got a little bit of code. Let's see if it looks any good. Oh, it's also wanting us to define it with a void return type, so that's fine. Print error, spawn monster click, and so get available random containment room. I like that. And then we should implement that actually. So let's implement this. And then monster type A, we actually want you to pick a random one of those. How do you pick a random one of these? Also, this should actually pick a random type. And then I'm going to give it this code so that it sends me back this format of like spawn monster the way we have it. That's the name of this button. If we don't, it might not. We just got to keep updating it every time, so you can't really copy and paste. Okay, so it looks like AI has listened to us and selected the right thing happening here. And let's take this. Oh, it's not finished. Writing the code out. So getting the random available containment rooms. So our getting a random monster type is going to have a function for that. It probably should null check that, but maybe not. Let's try. Okay, so now our ready is the same. We're going to get available containment room. If that's not null, pick a random monster type and spawn it. And then get the random. So find child rooms. Oh, we already have a get random available containment room. All right, so let's. Is it better than the one we have? Let's compare them because it looks like we already had one of these. We asked AI to implement it, but let's look at these. So yeah, same function name. So find child rooms, containment node, monster containment. It looks for the available rooms. Is currently containing a monster. Available nodes, the random number gen, the new number. Okay, so they're pretty close. It looks like. Well, we'll just see how it goes here. It looked pretty good. Let's see. Oh, is this callable thing? So I don't know why this must have been a change in a recent Godot thing where the syntax for wiring up those signals different. Cannot call method connect on a null value. All right. So spawn monster is null. So we're not finding this thing properly. let's send AI a screenshot of this and see if it can sort out. This is the part where it would help to know about this game engine, where I'm trying to figure out why this is null. I don't know exactly how they like to navigate the tree. So spawn monster is null. And it could be, if we look here, this find child. You know, we want like a recursive find child that goes down into the spawn monster button. But yeah, so it's not recursive. It's not a direct child, which is why it's failing. And so, okay, so this is kind of like Unity, where we're going to set up on ready. We're going to go and find this spawn monster button. Not recursively, but via this path, then to navigate this tree. And then, once we have that button, we can wire it up. So that's how this wants to work. Let's see if that works. Cannot call connect on a null value. So still null. Spawn monster button is still null. So what we're going to do is actually try to beat the AI to it. See if this path is correct. UI quota container. So it's not quota container, that's the problem. It's VBox container. It's not inside of quota container. Let's see if AI figured it out. So it's saying quota container from the path the button spawn monster is inside. So it is mistakenly reading the image I sent. So dumb AI. I'll bet you can't figure out bicycles and crosswalks either. How many buses are in the scene? Why can't you read this image and figure out the tree hierarchy? Okay, so now we've got this spawn monster button. We don't even know if it works. It definitely is going to try to run some code. Okay, let's see what's going on. Spawn monster. Brokey broke. So available rooms. Non-existent function empty in base array. Okay. Invalid call. Non-existent function. Empty in base array. So we check length maybe? Not sure how they deal, what the syntax is for the arrays in Godot, but it's dot size. If dot size equals 0. Okay, so that's the same thing. Let's see if that works. Excuse me, a little sneezy sneeze. So we're going to try to spawn a monster. No available rooms for spawning monsters. Okay, I'm going to go ahead with, there's a lot of rooms available, so our logic's not working. Uh, so containment node get children. So we have the rooms node, which is this guy. And then we have find monster containment, which is this guy. And those both exist, otherwise we'd have errors logged out. Now we get all the children of that thing, and the problem is they're grouped into top floor, bottom floor, middle floor. And so this is why it doesn't work. If you look at this hierarchy, And then you look at this function. We'll give it back to ChatGPT and say, hey, the hierarchy to find the available rooms is missing the level with top floor, middle floor, bottom floor. Sometimes you don't really have to be this explicit with ChatGPT, but it can help. So really what I want it to do right here is show me the way to get either find child recursively or maybe put these three in a list, which would kind of suck. We kind of would rather just search all of the, we'll just find all the containment rooms really. Um, and so this is saying for each floor, okay, in get children. So it's kind of this thing right here. So it's adding a level of, for each floor, now go get the children, and those are actually the rooms. So an alternate way to do this, which I would prefer better than like navigating this, because if someone changes rooms or monster containment, this is going to break. Instead, what we could do is actually get all of the things that have a containment room script, or that perhaps are a containment room type. So we just ask, is there a way to get the rooms by type, or having the containment room.gd script instead of traversing the tree? And that would make it much more resilient to someone coming in and renaming something, because instead of identifying rooms by where they were at one point in the structure, we're identifying rooms by what they are in terms of type. And then people can go in and change the names of floors and blah 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 and put 10 nests nested deep in there or whatever, and it doesn't really matter. Uh, so this is saying for each node in get tree, so this is saying, yeah, put all the rooms in one node called containment rooms, which I don't like that. So we actually have a method that we wrote that's better that we can use here in the worker. In the worker, we wrote this function that finds things based on the script that they are. Find thing by script. So it's recursive, and it works. Let's just put that up here, and now we can copy that. So this should probably be in a helper, you know, class. I don't actually know how to do that in Godot. We could figure that out, but we would have like a scene helper or whatever helper dot find thing by script, so we don't have to copy this thing over and over. But I don't actually care right now. It's not a big deal. So what we actually care about is getting these monsters spawning. And let's just put this in here for now and see if that works, because then we could do a find. What do we want to do? Find rooms. Find containment rooms. And they're identified by this containment. They have this containment script .gd. Is it room containment or containment room? Oh, this is awesome. Look at that. Room containment and containment room. Yeah. Okay. Yeah, it's that one. So find containment room, and that's a plural. And so instead of all of this, get random, like we could replace all this junk with var available rooms. And then basically look at all this we're going to kill. Let's do this, actually. For each floor, we don't need that. For each floor, for each room in find containment rooms. If the room's a containment room, we know that. If the room is not containing a monster, it's available. So, let's go with this. Get rid of all this junk. Spawn a monster. Ready? Broken. Alright. Node hitbox. Node texture. So what's busted here? Cannot call method get size on a null value. So texture is null. Okay. So we've got the situation where node texture.texture is null in add hitbox. So the answer to that, it's a little bit cold here. I'm going to turn up my jacket. The answer to that is I'm not sure yet, because now we've got to go through and figure out if, you know, the code for spawning a monster never seemed to be getting called, so we don't know how much of this is incomplete code or not. So let's see, the issue arises because the texture is null. Yep. And the texture might not be set properly or immediately accessible and ready when the add hitbox is called. Okay. So add texture seems to work because at least it doesn't crash. And then add a hitbox dies. So this is saying, so the func that it's providing here is so it's the same, it's checking for null. If not, it creates a new one. If the texture is null, so basically we're just going to log an error and not crash and continue on. So we'll try that. We'll give that a whirl, just see if we can get through this code and see if we can show anything on the screen. Spawn a monster. Spawned a monster of type 1 in room left 1. Okay. Let's just see how many monsters we can spawn here. It should stop at some point, because all the rooms will be full. So no available rooms for spawning monsters. Okay, so that code works. We've spawned a bunch of different ones, apparently. I see something in here. This looks like maybe a monster. It looked like that placeholder graphic we'd seen. And let's just find out where this monster press thing is getting called so that we can kill that now that we know it's working. Yep. Alright. Let's go ahead and kill the tunes. So, on our errors here, add hitbox. No texture is null. Cannot set the hitbox size. Fine. We are definitely trying to spawn a monster. So, random monster type. So we're returning a number. Is that what we actually want to do? I guess if this is an enum, is that okay? So yeah, so enums are it's kind of they're basically just like a predefined array of numbers that happen to look like a predefined array-ish of text. So that's why we're seeing monster type 1, even though we might want to see like feral cat, killer gorilla. So placeholder. All right, now I'm curious about how. So we had that yellow thing that showed up, and is that our monster? See everything. It seems like everything's a scene in Godot. So is that our monster that's defining that yellow thing? Yeah, entity placeholder texture. Okay, so it's this thing. All right. Uh, Fine. We can maybe tweak that in a minute and add some like a different graphic to it. I don't know. Maybe we have an artist that's going to come in and make things better. But let's see here. What we need to figure out if we're adding the monsters to the right spot because we were picking the right room, right? But I only saw the one monster show up. So we need to figure out if we're adding one of these yellow guys or a bunch of these yellow guys. Spawn monster. Nothing visually. So it's saying we're spawning a monster. Nothing. Nothing. There's one. So one showed up here. Remember last time it was over here. But that was type 0. So type 0 had an image, but not the others. Entity placeholder. Okay. So entity placeholder. Let's just look and see if this text shows up anywhere. Entity placeholder. Interesting. It's looking for. Well, there you go. So there's this assets.gd file that looks like it's defining the placeholder monster here, picture, and all these others are null. And maybe that's why we're not seeing them. So let's do this. What should we do? What should we do? We should programmer art this, right? Or do we want to pick some assets that I've purchased to just toss in there? They're kind of like pixel art stuffs. Programmer art's always entertaining, but some pixel art stuff would look cool. So let's go with we've got tunes. Where's this? Up here. Let's go with some pixel art. Pixel art. Let's see, there's this dungeon crawl. Monsters. They look kind of small. But I wonder if, like, how big are these? 400 bytes? 32 by 32? Little small. Are there any bigger ones? We could scale them up, but that's This for reference, this is like 222 by 504, which is a terrible. Don't ever do your art like that. Like, please put it in a square or something. Um, a good, hopefully it gets packed automatically, and then that matters less. But you know, because that would pack down into under 256 and under 512. Still huge, but you know, it's just nice to have stuff done in powers of two. Okay, so we've got these are like monster interface things. So the problem with those is that the picture runs off the screen. So let's look at this art here and see if we could pull any of these. So this is cool pixel art, but it's pretty small. Let's see if there's any big. These are monster faces. Oh, large. Hey, so these are pretty big. These are what? 366 by 280. So we're in the same kind of a ballpark here. And what do we need? We need a wild hound, a feral cat, a lone wolf. So I don't really like that we have three kind of wolf things. So maybe what we do is we change the monsters to be kind of like what these monsters are so that we have some art for them. Now, the problem is we don't have like a walk cycle or anything, but that's okay. We might have maybe there's an artist or something in the mix who can fix these things up. So what should we do? We should have, instead of a placeholder, let's have a beholder. Let's just replace that with beholder. Okay. And then in this assets entities thing, entities, assets, entities, project containment, assets, entities. We're going to ditch entity placeholder and we're going to put in uh, the beholder. All right, so I'm going to delete entity placeholder and I'm going to change it to beholder. Okay, and now we got to just make sure we don't screw this up because it's text. Monster type placeholder. Where's that? So this is going to be beholder. I guess there's no type checking on that. The entity placeholder. Okay, so this was in the Pew stuff. Okay, so there was a different entity, a monster called Equinox Love. Okay, so that's okay. So somebody drew that. So this stuff doesn't matter. This is in that old section of the code, and those were just basically placeholders too. So we're gonna get back to doing these monsters up. All right, so we got the beholder. What else can we do here? We've got. Should we do the scented dragon? We have a scented dragon. Which one's cooler? This one? All right. All right. So we're going to call it the scented dragon. So wild hound, we're going to replace with this preload. They're all going to be this path. So I'll just stub it out. Okay. So wild hound is not a thing anymore. These monster types, it looks like we were duplicating this thing. I don't like that, but this monsters dictionary, which is the assets, and then I'd rather have this assets thing be tied directly to that other enum, but it's probably not going to happen easily. So let's just fix it as we go here. And then, okay, so we've got a Scinta Dragon. We've got, this is actually going to be quick load. Let's just find a beholder. All right, that's fun. And then we need to do some more monsters. So we've got Feral Cat, which we can make be this like burly Cyclops guy. Let's do a Cyclops. Instead of Feral Cat. And then we're going to do, there's a crazy flower thing. There's this Fury, whatever that is. A Gold Man, which I think we're kind of looking for creatures. This is more of a robot. Uh, there's an ink blob. It's kind of cool. Maybe it's, you know, almost like a Venom kind of thing. There's a Kragadon. Let's go with the Kragadon. Oh, this. So how many more do we need? At least 3? Yeah. So we've got. What else would be cool? Maybe the Scarecrow makes sense to be a monster. We have. Let's pick one of those. Which one's the cool Scarecrow? I don't know. This guy's cool. Let's go with the Scarecrow. Okay, Lone Wolf's going to be a Scarecrow. And then we want the Kragadon. I think's the right one. That'll take out Muscular Cow. And then we'll go with, finally, this. Do we want this crazy ink blob thing? Let's try it. Let's go with this crazy ink blob thing. Inky. And then we got Inky. Alright, so those are now our monsters. And now let's see if these things happen to load. See if that's how the loading happens, or if we've got something else to deal with. Okay. Spawn monster. Hey, look at that Scarecrow guy. We got the Beholder. We got the Cyclops. Another Cyclops. Another Cyclops. Another Cyclops. Inky, Cyclops. Scinta Dragon. I don't know where that one went. Did I miss it? Was a Cyclops again? Inky, Kragadon, Scarecrow, Scarecrow. Alright, and then we're out. Cool. Okay, so now we have those guys going. So let's see if we've got, let's just see if we've got any other, like, do we have a drawing that would work for our worker, basically, right? Like, what should our workers be? Do they look like doctors? Do we have a doctor? Do we have the chemist? I commissioned a bunch of chemist art at one point. These are tiny. We want something bigger. want this Chemical Bard, Pixel Champions, Battlers. So these are all tile maps. Let's see. Final Boss Blues does awesome stuff. If you haven't seen Final Boss Blues, I recommend just buying everything he does. It's really good. Really good. In this case, it's a lot of small stuff. I wonder if he's got any big stuff. If it's all small stuff. That's the nice part about the Tyler Warren stuff is he's got a mixture. He's got some of this stuff like this. Yeah, let's find something in here. So let's just search for. Well, let's do this MB large. These are pretty big, right? Yeah, big enough. All right. So we've got even crazier monsters, huh? Let's see. Fallen Hero. What should our doctors look like? The first 50. The second 50. What should our doctors look like? We need big. We want our dude walking around to be what? None of this stuff, right? Just keep looking. This okay, so we have Dark Lord. We kind of want like a doctor or nurse or something. Shadows, okay. Monster Evolution. So that's what we just kind of snatched stuff out of already. Time Fantasy Tribute. Man. Are we going to get anything that's like a character? We need large characters. What we need, right? Super boss. Maybe we're boss. I don't know. What does that look like? No, they're just insane. Alright, so that's probably not going to work. Slenard. So, Salil. She does some good stuff. She's done a lot of custom art for me that I paid for. um, let's see, I got some of it. This is the custom of me that she did. Back when I was rocking 2 mohawks, before that meant you were insane. So, back when it just meant punk. Oh, let's see. I wonder if I could do, because this was my character, but that's too small, right? But we do have a tile set for it. I don't know that we're going to be doing tile sets. Rexar does icons. King Rabbit does some good stuff. Lesser overworlds. Let's see, creatures, buildings, towns. Heroic. Yeah, this is all kind of like small stuff. Well, we got to figure this out quick, right? So maybe we just leave it for now and we let someone else figure out. Because right now it's just this. It's the like the Redot icon. So at any rate, we've got our monsters in there and they spawn. So perhaps instead of, you know how we're spawning them with that button, what we need to do is put them on like a timer or something like that. So, all right. Well, I'm going to get some breakfast, and then we're going to come back and try to get some monsters spawning dynamically. So, stay tuned. Thanks for watching, y'all, and I'll see you in a few minutes.